Alright guys, we are starting Unit 11 today, and Unit 11 is all about logarithms. So today our goal is to figure out what a logarithm is and how to convert between logarithmic form and exponential form. So all a logarithm is the inverse of an exponential. When you're solving for a logarithm, you're really finding an exponent. So a logarithm, you've seen the button on your calculator. It's a log. It has a base. You're taking the log of something, and it equals x. So this is your base. This is what you're solving for, and this is your exponent. So it's written as log base b of y equals x. Remember, our exponential form was y equals b to the x. Notice the base of an exponential becomes the base of a log. So if you were going to go from one form to the other and you went in a circle, b to the x is equal to y. Base, exponent, what you're taking the log of. Alright, so look at example 1. Log base 3 of 9 equals 2. The base, I want you guys to write this in exponential form. The base of a log is the base of an exponent. The exponent is what it equals. So I would say 3 squared equals 9. On B, if I go around counterclockwise, the base of the log becomes the base of an exponential. 8 to the 0 equals 1. 5 to the negative 2 equals 1 over 25. Okay? So if I go counterclockwise around a logarithm, you should be able to take a log and convert it to an exponential form. Likewise, if I go the other direction and I'm giving an exponential form, like let's say I go this way. Log base b of y equals x. If I go clockwise, the base of the log is the base of the exponential. What it equals is what you're taking the log of, and your logarithm will always equal the exponent. So, for example 2, I want you to write 3 squared equals 9 as a logarithm. Log, the base of the exponential becomes the base of the log, equals 9. Log base 3 of 9 equals 2. Your logarithm always equals the exponent. So on B, log base 2 of 1/2 equals negative 1. Log base of 1/4 of 16 equals negative 2. The base of the log is the base of the exponential. The exponent is what a log equals. Log base 8 of 4 equals 2/3. Okay? You are expected to know those rules and how to convert from one form to the other. Okay? The base of the log is the base of the exponential. The exponent of an exponential is what a logarithm equals. So when you're solving a log, you're really finding an exponent. Okay? Now I know when we're typing logs in on our graphing calculator, there was 2 different buttons. There's a button on the calculator that says log, and then remember when we went to math and we went to log base, we could have the fill in the blank logs. So if you use this button on a calculator, that's a common log. That's a logarithm with a base of 10. So anytime you have a logarithm and you don't see a little number down there, you don't see the base, it's automatically a base of 10. Okay? So like example 3 says, evaluate to 4 decimal places the log of 7. I could write this log if I wanted to as log base 10 of 7. Since it has no number down there, I know the base is automatically a 10. So this is just getting you used to using your calculator, right? Log 7 equals 0.8451. Log of 0.25. Negative 0.6021. So if I wanted to check it, I could say 10 to the 0.8451 should give me 7. 10 to the negative 0.6021 should give me 0.25. And then log of negative 4.2. It says there's an error. You cannot take the log of a negative number. Okay? Alright, so that's fine and dandy if you have a calculator that just has the log button on it, right? But what, and you had a base of 10. If you're at home and you have a scientific calculator or the calculator on your phone, and that's what you're using to do your math, you don't have a fill in the blank like this on your scientific calculators or your graphing calculators. Your calculators will only do logs in base of 10. The only reason why we have this is because we have a graphing calculator. So there has to be a way to do a logarithm. Oops. There has to be a way to do a logarithm at home for you. And that's using the change of base formula. If you have the log base b of y, if I wanted to figure out what that was, but I didn't have a fill in the blank, you could take the log of y and divide it by the log of the base. And it'll change it to common logs. Okay? So if you take that and you type it in your calculator, you should get the same answer. So like on example 4, if I want to know what log base 4 of 64 is, on my graphing calculator, I could hit math, I could go here, and I could type in log base 4 of 64. And I would get 3. But if I don't have that, I could type in also the log of 64 and divide it by the log of the base 4. So I should get the same answer if I just use the logarithm button. Log of 64 divided by log of 4. And that's how you would do these problems if you just used your phone or you used a scientific calculator. I get the same answer. I just don't have the fill in the blank options. Okay? So like B, log base 2 of 15. If I was doing this on my phone for homework, I would take log of 15 and divide it by log of 2. Log of 15 divided by log of 2. And I get 3.91. Log of 1/4, log base 1/4 of 50. I could take log of 50 divided by log of 1/4. Log of 50 divided by log of 1/4 is negative 2.82. Log base 32 of 2. Log 2 divided by log 32. Is 0.2. Okay? So again, when you're finding a logarithm, you're finding an exponent, right? If I wanted to check this, base exponent is 4 to the third 64. Is 2, is my base, to the 3.91, 15. 1/4 to the negative 2.82, does it equal 50? 32 to the 0.2, does that equal 2? Okay? You can always check your problems using from a logarithm to an exponential or an exponential to a log. Okay. Like I said, when you're finding a log, you're finding an exponent. An exponential, which was in Unit 10, and a logarithm really can go hand in hand because when you're solving for one, you're solving for the other. So let's graph y equals 2 to the x and see how it relates to a logarithm graph. So if I go to y equals and I type in y equals 2 to the x, we see our graph. It's an exponential growth. And I can go to my table and I can fill in my table. So at -3, we had 0.125, 0.25, 1/2, 1, 2, 4, and 8. So if I graph that, 0, 1, 1, 2, 2, 4, 3, 8. This is an exponential graph, right? Really, fix that, right? It doesn't go below the x-axis, it hovers right there. All right, so when I go to graph y equals the log base 2 of x, and I go to y equals, since I have a base of 2, I need to use my log base and my fill in the blanks. Log base 2 of x. This is what the graph looks like. When I go to my table, notice at 0 I have an error, and then it goes from there. Okay? So at 0, I had an error. At -1, I had an error. What are some other points that we have here? Because I have a table that I need you to fill out. 1, 0, 2, 1, 4, 2, 3, 8. So 3, 2, 1, 0. So how can I find the answers for 0.25 and 0.5, right? If you notice, from an exponential to a logarithm, look at these rows. All of these numbers are just flips. The y's became the x's on a logarithm, and the x's of an exponential became the y's. So 0.25 is at -1, and so 0.25 is at -2, and 0.5 is at -1. All the logarithm is the flip of an exponential. So if I graph this one, over a quarter and down -2, over a half and down 1, 1, 0, 2, 1, 1, 2, 3, 4, 2, 8, 3. All right? So you should see that a logarithm graph and an exponential graph are just the flips of each other. Okay? One will undo another. You know how, like, if you had x squared and you took the square root of it, they would cancel? A log would cancel an exponential, and an exponential can cancel a log. So let's practice some graphing logs. You guys have gotten really good at typing stuff in the calculator and graphing them, so this shouldn't be too hard for you. Remember, a logarithm graph, just like any other graph, can shift. If there's a number with the x, remember that shifts it left and right. So if it's plus, it goes left. If it's minus, it goes right. The number at the end will shift your graph up or down. And these logarithm graphs, wherever you see an error, that's where your asymptote is. So remember, on an exponential graph, let's see, on an exponential graph, there was a horizontal asymptote. It couldn't go below a certain point, right? So on a logarithm graph, it can't go vertically past a certain point. So notice in your first example, it says y equals log base 4 of x plus 2. Graphing this, log base 4, x plus 2. Well, if it's plus 2, you should notice the graph of a logarithm shifted over left 2. So this tells me it's going left 2. If I look at my table, notice in my table, my first error is at negative 2. So at negative 2, I have an error. That means at negative 2, my graph cannot go past this point because that's where my error is. And then what can we graph? Negative 1, 0. 0, 1/2. So negative 1, 0. 0.5 is an easy plot to point. How about 2, 1? What else can we graph that's pretty simple out of here? 6 and 1/2, 1.5. And then we're off the grid. I mean, you can graph all the decimals in between there, but... So negative 2 had an error. That's my asymptote. So negative 1, 0. 0 up 1/2. Over 2, up 1, and over 6, up 1.5. So the graph is curving like this. Now there's so many points between negative 1 and negative 2 that you don't see in your table that you really just need to take the graph and curve it down along that asymptote. Okay? So let's look at the next one. Log base 2 of x minus 1 minus 4. Log base 2, x minus 1 minus 4. When I look at this graph, you should see the graph shifted to the right 1 and down 4. Right? That's what those numbers there are telling us. So going to my table, when I look at my table, the first number that gives me an error is 1. That means at 1, there's an asymptote here. So if I go where x is 1, I can draw that vertical line. That graph cannot go past that point. So from here, I can graph 2, negative 4, 3, negative 3, 2, negative 4, 3, negative 3. What else can I pull out of this table? That's pretty simple. 5, negative 2. Anything else? How about 9, negative 1? So over 2, down 4. Over 3, down 3. 5, negative 2. 9, negative 1. So this graph is curving this way. And like we said before, there's so many decimals between 1 and 2. Right here, between that and my error, my asymptote, that this graph is just going to keep curving down along that asymptote. Okay. So I hope you are comfortable graphing logarithms. You really need to practice, finish your practice pages on this converting. Can you take a logarithm and write it as an exponential? Can you take an exponential and write it as a logarithm? You need to feel very comfortable going back and forth between the two forms, okay? Remember, the base of a log is the base of an exponential, and your exponent of an exponential is what your log equals. All right, I will see you in class, and we will practice more of this tomorrow.